So I'm going to introduce the last talk, the last presentation of today, which will be given by Actility. So Alper Yegin, who's the vice chair of the LoRa Alliance, the chair of the technical committee, and serves as a VP of Advanced Technology Development for Actility. And Thior, who's also with Actility for a little bit more than 6 years, responsible for the operation in North America and Latin America. Thior will show you geofencing, geolocation demonstration with roaming. So that's really cool, bold from him. So please come on stage, welcome.
Thank you, Olivier. It's a pleasure to be here. And, okay, here's the pointer, right? So, as Olivier explained, so we're going to be doing a demonstration and explaining the whole story behind it about how to build an end-to-end solution using a LoRaWAN tracker. And it won't be only using this plain LoRaWAN, but also we're going to show how to leverage roaming. And I'm on stage just to talk about the roaming technology part, and then I'll leave the stage to my colleague Thior, who will walk you through the end-to-end use case and the live demonstration. So, okay, let me stand up like here so that I can see the. All right. So in LoRaWAN, just like any other wireless communication technology, we do support roaming. But the way we support it and the kind of features we have goes well beyond what people are familiar with from Wi-Fi world, from 3G, 4G, and even 5G world. So we have numerous use cases. The very first use case is building international complementary coverage. So we have several nationwide LoRaWAN networks, and they have users whose assets would go beyond their home country. And what we do is simply set up roaming between these nationwide networks to extend their coverage across multiple countries. That's the very traditional way of setting up roaming and the use case. But we don't stop at that. With LoRaWAN, let's take a look at the case two, where you can have multiple networks within the same country with partial coverage. And again, we leverage LoRaWAN roaming, so these networks can be integrated together to present one nationwide network to their own subscribers or users. Then the third one, which stems from a technical feature we have, we can have multiple networks in the country with overlapping coverage. And I have a specific slide to show how we leverage overlapping coverage. And then these two networks can also set up roaming, and wherever one has a weak coverage, the other one becomes complementary. And they can do so without having to do any planning. The end devices end up using the cumulative coverage. So we have this additive effect of multiple layers of LoRaWAN networks working together. And with the latest development of launching satellites with LoRaWAN gateways on them, we've been able to provide coverage from space, including low Earth orbiting satellites, which are flying 500 to 600 kilometers, and even geo satellites, geocentric satellites that are above ground around 30,000 kilometers. And we've been able to set up roaming between the terrestrial networks and satellite networks. So the coverage that's been achieved through the satellite networks, they have been added to the coverage provided by the terrestrial ones. And we've been also able to do this not only among the public networks, but also private networks and community networks as well. So due to the low-cost nature of the LoRaWAN infrastructure and the unlicensed band operation, we've been seeing networks being built for private uses, like the enterprises building their own networks, to serve their own devices, and even the community networks have been emerging. And the roaming equally applies to all these three different types of networks, both on the ground, terrestrially, and also in space. So in the traditional sense, LoRaWAN roaming is a necessity for coverage extension to take the networks beyond local area networks or beyond the national borders. And we have numerous networks that have already set up public-to-public roaming. And the other benefit we get out of LoRaWAN roaming is coverage densification, and that's one of the major differentiations of the LoRaWAN technology. So we have this feature called microdiversity, meaning that the end device, when it transmits an uplink frame, it can be demodulated by any one of the gateways within the coverage. Unlike Wi-Fi and cellular technologies, we don't have the concept of attaching or connecting to a base station. In our architecture, the attachment, connection, or the join is with the network server behind that. As such, the device doesn't have to pick a gateway and attach it, and then pick another one and attach it again. Instead, upon the successful join procedure, the end device ends up joining the network through the network server, and then it can leverage any gateway at any point in time under the control of that network server. And with the roaming, that list of gateways receiving the uplink frames gets extended to include any gateway being managed by a roaming partner network server. So through that, when two networks are roaming and when they have overlap coverage, all of a sudden, the experience by the end devices, it feels like it's being served by the cumulative collection of gateways from two or more networks. So the end device could be seen as at home because it's under the coverage of the gateways from home network, and also be seen as roaming into one or more other networks at the same time. So the net effect is the network densification by multiple networks collaborating to appear like a single network with the accumulated with the gateways added together. And when you have a higher density network, the device battery consumption reduces because through the adaptive data rate, the end devices start transmitting at higher data rates. And when they transmit at higher data rates, time on air gets shortened, which reduces the interference. And as such, it increases the network capacity. And also the geolocation gets improved because now many more gateways could be receiving the same uplink and fine time stamping and turning them into geolocation information. So roaming is beneficial to the end device and to any network involved in that setup. And that's very unique to LoRaWAN. You would not see this happening with any other competing technologies. And with that in mind, around 3 years ago, what we have done was, so first of all, we have commercialized roaming feature on our network server, and then seeing that as the number of networks are growing, the next challenge was how to facilitate networks interconnecting with each other. So stealing a page from the past communication technologies, we said, the way to scale interconnection is to build roaming hub. So with that, we have built ThinkPark Exchange and started forming the backbone of LoRaWAN. And what you see is more than 30 networks using ThinkPark Exchange. The ones at the bottom are the public networks. Some of them provide nationwide coverage like Orange, Swisscom, KPN, Proximus, and Digita. And many others provide public service in their respective countries. And at the top on the left, what you see are the satellite networks. And then the middle is the private enterprise networks. And then you see the community networks, one of which is Helium. And the demonstration includes roaming between a private network and the Helium network. And then you see the academic networks and the activation servers. So among this collection of network servers, we demonstrated, and people have built commercial agreements to have public-to-public roaming, public to private roaming and private to private roaming as well, and those including both the terrestrial networks and the satellite networks. So that's the part that I cover, and then I turn it over to my colleague Thior.
Thank you, Alper. Thank you. So yes, for today's demonstration, I'm actually going to show you a roaming use case between the ThinkPark community network and the Helium community network. And so the idea is while you have both network on their sides with their gateways, their network server, they are connected through the ThinkPark exchange. And so what we're going to do is I'm going to have the, and I think, yeah. I'm going to have the, no. Can you go back to the slides? Yeah. So I'm going to have the device, a couple of devices set up on the home network, showing you the geolocation use case. And then at some point, I'm going to shut down that gateway, and we'll see that we'll still see the data coming through the Helium gateways. So in terms of setup, just to show you exactly what we're going to use for the demonstration. For the home network, we're going to use the ThinkPark Enterprise Network Server in its community version. In terms of trackers, I'm going to use ABO trackers. So trackers I brought are micro trackers. And yeah, the idea will be I set up a couple of BLE beacons around the room, and we'll be able to track those trackers inside the room. Just a short word on the technologies, because when we talk about geolocation, if you're familiar with the subject, it might be obvious, but if you're not, it can be a bit confusing. Just before, Alper was talking about densification of the network that you can use to improve the geolocation, and that's when you are using the actual network to geolocate any device. So that's one way of finding where your device is. But you can do that in many different ways. When you have a tracker, usually they will embed one or several technologies that can be used to see where they are. The most thing you can have in mind is using GPS on your tracker. They will give you their coordinates, you know where they are. But when you are indoor like this, usually that doesn't work so well. So you could use something like sniffing the Wi-Fi's if you have a dense enough Wi-Fi network, or in what we're going to do today, using BLE beacons that you can see. I have one at the bottom of the podium here, and I have a couple in the room. So that was on the network server side, the device side, and then on the other end of the solution, I'm going to show you two applications. A B2B application that we call ABO Device Manager for those devices. And the idea is more on the admin side. Maybe you want to configure some devices. Very often you will want to be able to troubleshoot the devices. And so you have a number of tools that are available through that application to do that. So that's one example of application that you can build around the geolocation use case. And the other one that I'm going to show you is a B2C application. So something that I'll show you on my phone that gives you a simple use case of finding your device and setting up some alerts and geofencing around the device. No, yes. So I'm now going to start with the actual demonstration. And so I'm going to go from really going to build that use case from end to end. So here I'm going to log on my community network. Oops. Same player, try again. I need my one-time code, security. And so that's an account that I created for that demo. And at this time, there's nothing in there. So I have no base station, no devices. So I'm going to start by creating a base station. I did plug one on the back of the room. And I did prepare all the keys that we talked about earlier in the trainings. One thing that is rather important, and specifically in the US, when you want to do roaming, so in the US, as you know, you have 64 plus channels, and very often, if not most of the time, the gateways are going to use 8 of them. So when you do roaming from one network to the other, it's super important that both networks are using the same channels, otherwise you might end up with problems. So in this case, I'm setting up my channels to match what Helium is using. And in this particular use case, my gateway is using a key pair to authenticate on the network. So I prepared that one in advance. So that's it for my gateway. In a few minutes, it will come up. In the meantime, I'm going to create what we call a connection, which is another way to say an application server where we're going to send the data. So for this demo, I'm going to create 2 application servers. One is going to be my mobile application, and the other one is going to be my B2B application. So same thing. So just sending the data. So in this case, mobile app. Sending my data here. In this case, I want my data to be XML. I have an authentication key that my application is expecting to receive. And that's it for this application. I'm going to create a second one, very similar. So we talked about the B2B application called Abiwa DMS Manager. I'm going to get the URL. In that case, I'm sending XML again. And I have, in this case, the same key. So now that I have created the application I'm going to send the data to, now I'm going to create the devices. Okay, so I have 2 of them, one with me, one I left to Alper. So in my case, those are the micro trackers I showed earlier. Looks like key fobs. I'm going to create Alper's one. The Thior 6. I have my key. So all the keys that we talked earlier today, so the dev UI to identify the device, the journey UI here, and the app key specific to my device. I could have used the QR code to create those, but was a bit too fancy for me. So I'm going to send this one to ADM. And one important thing, so on my account, I do have roaming agreements between Actility and Helium. And so when I create my device, I want to activate that roaming capabilities because there are fees associated to it. And I'm going to create a second device with that. Demo effect, I guess. Let's see. There we go. So I'm going to create my second device. Getting all my keys. And sending this one to the mobile application. Activating roaming here as well. And here they are. So now that my devices are on, I'm going to check that my gateway came back up. So it's green, so it's up and running. Go for it. Here I have the channels that I chose. It's telling me that it's active. It's still just starting, so I don't have the network information yet. But it's up in there. So now we can start the devices. So another thing that you probably know as well, in the US with the 64 channels, most of the devices will kind of have to find the right channels to hop in. So some device makers will set up the devices to a specific subband. In this case, they're going to hop through the 64 channels. So there's a randomness to it. So in my case, they're blinking red and blue, so I know they're trying to join. And I'm going to receive a message, and they're blinking red, telling me that the join failed. So I could just wait, and in 5–10 minutes, it would join. In this case, I'm going to try to speed things up by pressing the button again. And hopefully, in a couple of tries, it should tell me that it's joined. Blinking blue and red. Still not. So Alper's device just joined. That's the noise that you heard in the background. And so the idea, so with those 64 channels, you have those 8 blocks of 8 channels. And so the device is normally hopping randomly to those 64 channels. What device maker, or at least on the ABY device, what they're trying to do is they're going to hop on each block once and then go back to try and reduce the number of attempts that you have to do. Let's see. Not been lucky on that one. So while this is joining, I'm going to show you the other piece. Okay. There we go. So my other application, the B2C application, will allow me to do a number of things. So I told you that we're going to geolocate those devices in the Bluetooth beacons that I set around the room. But right now, my application doesn't necessarily know where those beacons are. So that's something I'm going to have to define. So logging to my B2C application. Let me see. I have my device I configured to go to that application. So I'm going to select it. And so I told you that the B2C application and the B2B application have different purposes. So on this B2B application, I will have a lot of technical details of my device. Things like the firmware version that I can have on that device. Things like the dates of the different positioning. But I also have statistics on what the device is using for data rates, per factors. I also have a number of tools at my disposal. If I go to the performance monitor, it's going to allow me to see a number of things over time. So the dashboard and graphs we talked about earlier today, showing me either the battery level in this case, but I could also see if I have some packet loss, the RSSI distribution for a given device. And this in the end will allow me to troubleshoot something that could be happening on the network. The typical case that I will have to troubleshoot will be the packet loss will be probably the main one. In this case, I have very few packets, so no packet loss at all. Other things I will be able to see is the message that were sent to that device. So being a tracker, the different devices that it can send are, of course, position message. So in here shown as blue. But I also have heartbeats, so messages just sent to the network saying, hey, I'm alive. It's a very cheap message, so it allows to save battery. And then I have other things like events or device shutting down, turning on, things like that. I also have access to the device configuration, so something you might not want your end user to have access to directly or not completely. Because you don't want your end user to end up with a device that is not working. On the case of that device, there's a lot of configuration available from when the device is going to send a position message, either when it's moving or all the time regardless of what the device is moving, to the timing between those messages, but also the technology used by the device. So it could be GPS, could be BLE and GPS, Wi-Fi, mix and match. And you have a lot other configuration there. So as an admin, I might want to have access to that kind of thing to set my initial configuration and then go to factory and say, okay, this is the configuration I want to my use case. And go with that for scalability. Other thing you can see is the messages themselves. So the device is sending messages to the network. And so I can see the content of that device. So in this case, I had a position from BLE. I have some coordinates here from previous test I made. And I have the message itself. I can look at the message itself. And because it's a BLE positioning, what the device is actually sending is just the IDs of the beacons I put in the room and the signal power corresponding to those beacons. And then it's the application on the back end that is going to do the triangulation to tell you where the device is in regards to that beacon, to those beacons. There are also some other tools that will allow you to see, for example, here, for a given configuration of the device, what is the battery expectancy you can have. So really something oriented to the B2B admin distributor that want to manage those device fleets. And the part I want to show you here is the map piece. And so those are my previous data. But what I want to show you is here I just have the Google Map equivalent of where we are here, but there's no information about my beacons, and that's what I want to set here. And what we're using is a GeoJSON type of configuration. So basically a standard document that will show you the location of your room and the location of your attributes, in this case, the beacons. To construct that, you can do that any way you want, respecting the open format. An easy way to do is to go to places like geojson.io or any other place that would do something similar. And if, for example, here, searching for where we are. And so we are over here, I think. Fairmont. Markup kits, so we are here. So I don't know exactly the position, so that's going to give you an idea of how to do those things, but let's say if I'm not completely mistaken, we should be around here. So I'm just building that room, and the other side is going to give me the coordinates. If I had the real coordinates, if I wanted to do something very precise, then I would need to know the exact coordinate. But a tool like this just gives you a possibility to build something quickly. The other things I want to do is put the beacons I placed in the room. So the beacons I placed in the room, I put one in the window about here. I put another one close to the door about here. And I have one close to the podium, let's say around here. And now I'm going to define the attributes of those devices. So I'm going to give a name to this one, the door device, and I'm going to give its ID. So the beacons are already configured and they are transmitting a specific ID. So these I wrote down before. And I know that the one I put close to the door is going to send me the ID 01. So I'm telling to my map, this one is beacon 1, the one to the podium, one in front, and the FD of this one is 03. And the last one, close to the window, is 02. I save this. So now I have on the right side, so the coordinates of my room, and then below that I have the ID of my BLE beacon and the corresponding coordinates, and same thing for my other 2 beacons. And so this is the map that I will be able to load on the application for the application to then triangulate and find out where my trackers are. So if I take that and replace what I did before and go back to my application will allow me to load that map. So I want to load it to solve the position and upload this. So now I can actually display the map and display the position of my beacons. So one thing I will do is I will remove all those to just show you the one that we're going to create now. But this is the idea. So now I really send to my application the information of where's my room, where are my BLE beacons, so now we're going to be able to start geolocating my devices. If I go back to my network server and I'll check my devices, so mine have left him alone. And this one is the one from Alper. So this one has sent 23 positions. So I can take a look at here. It sends the position to my B2B application, and I can see the data here. Right now, all those data, all the gateway that is used is the Actility community gateway. So that's the straight case. I can check what the message is saying. I can see, so what I described before, it's seeing a number of the BLE beacons. And so Alper was, the device is configured in motion tracking. Alper is moving very much, so it's static and gives me information on the temperature. The devices also have a capability to send you SOS message, so like a panic button. So in this case, I know the panic button is not used. So it gives me that information here. Now if I go back to the application, I can reload the data and see what happens since Alper received the data. If I go back to my map, now it should zoom into where I am. And we see Alper here at the front. So that's basically the idea of that geolocation. And if I click on the location itself, so I have more information about what are the beacons that the device saw for that location, when it happened, information on the network side, so what spreading factor were used, the RSSI, basically everything you had in the packet. Okay. One last thing that didn't show also on the B2B application in terms of configuring devices. So you can configure devices here, choosing the options and all that, and that's fine. But you know that to configure a device, either I would have the device on my hand and modify the device itself, but the tool allows you to create payloads that you're going to send to your device through your network server. So if you plug this application to your network server and click on update, it will actually send that new configuration to the device. But if the application is not plugged into your network server, you always have the ability to get the payload itself. And there you have the actual hexadecimal payload that you could directly plug into your network server. It can also be used if you want to embed that into your own application. So to check what would be, if you want to have that specific configuration, what it would take as a payload to send it. And it describe what exact message is sent here. And if you have a lot of configuration that is changed, then you have different messages that would need to be sent. So this one, like the first message is just going to change the mode, while the second message with the larger payload is going to set a number of the parameters for the geolocation. So that's what we have for the B2B application. 04. Let me see. I'm not having luck with that second device. Let me see again. I think I'm going to abandon that one for the moment. Let's see if I can go back to that at the end. So now that we have that first device that is up and running, that is sending data, that we're able to geolocate where Alper is, the other part of the demonstration is really about how can we roam and how can we see that we're roaming. In my case here, I know that my ThinkPark community network is not deployed here. I only have one gateway. I can confirm, so here it tells me that the best gateway is this one. If I want to check more details, I can go in there and try to see the list of gateways that receive that message. And so let's see. And in here it tells me, so there's only one line, so there's only one gateway that receives that message. So I know that if I shut off that gateway, I don't have any more coverage here. So from the user interface here, I can go to see my base station. And in the option, I'm going to just turn off the radio. So I have a number of things that you can do. One of them is stop the radio of the base station. So what it does is the base station being connected to the network server. Here from the UI, I'm having the network server send a message to the gateway to stop its radio. So it takes a while to have the confirmation from the gateway. And so now my radio is stopped. Now what we should see is in a few packets, we should see the packets coming to Alper's devices coming from the Helium network. So while it's doing that, so it's been too long for that device. So what I'm going to do is, in case I did a wrong copy paste, I'm just going to remove it. Maybe I took twice the key of the other device. Let me try that again. So micro tracker, and this one is the 04. Phone device, Johnny UI, app key, and sending this to my mobile app. Activating roaming, and let's try again. So on that particular device, one thing that is nice is really that instant feedback I get from it. Although there's no screen, there's nothing, just the LED tells me if it's blinking red and blue, I know a join is being sent. If I have multiple red blinking at some points, it's telling me that the join failed, so I know that something needs to be done. On some devices, when you have absolutely no feedback, it's a bit difficult to figure out what's happening. Let's see. Nope. I'm going to give you 3 more tries, and then I'm going to give up on it. Nope. All right. So let's see if I can still show you the mobile app with that device, but I think that's going to be difficult. There it is. So I probably did mess up the keys at the beginning. And so now in this case, because I shut down my base station, I will show you something that I didn't think of showing you before, but so the device actually joined through the Helium network. So earlier today I was doing some work with it, and so you see those arrows, regular arrows, those were on the Actility network. And then I have some packet that stayed passive roaming. So here I can see the join request and join accept that were sent through the Helium network. So in here I will just see the data from the device itself. But if I go back on wireless logger, so this view, I will have more details. So in this case, it's going to give me some information about the network the device roamed from. So with the network ID mainly, and the gateway that was used on the Helium network to send my message. And so now I have my new device, and I also have a device that Halper is having that also goes through this passive roaming. And so now that my device is up, let's see if I can show you the B2C application. Yes. So let me. Oops. Connect my phone. There we go. So I have my okay. So I have my device that was detected. So I know it's the device number 4, and so now I'm going to add that device to my mobile app. Maybe. No, it's not there. Ah. shouldn't have paired with it. So that's the life of the demo effect, I guess. It's not there. No, I think I did something bad with my device. Okay, so I'm going to skip that part and go back to the roaming piece. Oh, it does allow me to show you the application. So on the application side, so once the device is paired, what you should see is the location. So the device is going to connect to the phone, use the phone's location to tell you where the device is. So in this case, because I'm not connected, it's not correct. And from there, you have a number of things that you can that you could do. And again, I don't have the option because my device is not added. But the idea would be from that application, you're able to create a zone. And so this is a lot the idea, what I wanted to say on the B2C application is that it's a lot more simpler than what you have on the other one. There's no way for me to define those Bluetooth beacons around the room. And so when you create a zone for that device, it's going to be a larger zone. Typically in this, it's about 300 feet around the device. And you're able to say with that mobile application, if the device is in or out of that zone. You're able to set alerts that tells you if the device is getting far from your phone or if the device has the SOS mode activated. So if you configure the device so that your phone and someone else is using the device and activating the SOS mode, then you would have the information on your phone. So it's something a lot simpler than what you have on the admin side, but something that could be used from an end user perspective. And so unless I manage to pair my device, that was the end of the demonstration. So really to show you that even with the gateway disconnected here, that I still receive the messages from both of my devices, going through the Helium network in this case. And so for going back to the B2B application, I don't think Alper moved much, but we'll still see his device sending data to where he is. So I'm still seeing where Alper is at the moment, right here. And I can see in my logs, so the data coming from the Helium network. One thing nice here is, so we discussed the sequence number, so the F count number. And I can see that when I did the roaming, the sequence number didn't lose anything. So I went from the 20th packet sent by the device received by the Actility gateway, and then I do see packet 21 and packet 22 sent to, through Helium gateways. So that's a nice thing in terms of, okay, I can see I do have good coverage here. And that will be it for me. If you have any questions.
It's a little less of a question, but more of a statement. I think there was a gateway in the building to sort of back up the Helium network. I think it went off about 45 minutes ago.
Mm-hmm.
So all of that was through the real Helium network.
Yes.
And it may have been the same reason that that device didn't connect. It seemed to be having some internet issues back here.
Well, actually, here you do see And you will know more than me, but you do see that the gateways that were used are two different gateways.
I couldn't tell you the name.
So
of
yeah,
the
it's
gateways,
using the
but
real Helium
yeah.
network.
We could probably cross-reference them, and they'd be the same ones that I'm testing with my device. So.
Good, good, good.
So maybe if you could introduce yourself, Joey, that would help you when you say.
Oh yeah, so I'm Joey Hiller. I'm with the Helium Foundation. So this is like my nerdy domain in terms of all things Helium network.
Cool, thank you.
And, yeah, kind of down the row as well. Jeremy is with us as well.
So the setup for roaming was very simple. You kind of
Yep.
skipped to the end by just clicking the on or off button. Is there a significant effort to set up the actual connections to multiple networks? I mean, there was a wide number of networks that are supported through the exchange.
So, and I think I'll probably have more to say about that, but technically not really. The effort will be more into setting up the agreement between the two networks.
Right. Yeah. What you have seen was enabling roaming for a given end device, given that the networks behind the scene have already set up roaming between the two. So the network server, the community platform that where Thior provisioned the end device as its home network has a net ID, and it's connected to the ThinkPark exchange. And so is the Helium network connected to ThinkPark exchange with its own net ID. And we have done was we have set up peering between the two. So among all these 30 networks that are on the ThinkPark exchange, the roaming hub, it's just a matter of opening the flows by turning another similar knob so the traffic can start flowing between the two. That had to be done in advance. And if I were to like enumerate the steps, so you have two network servers, they should have their net ID, and then they should either be interconnected back to back or via a roaming hub, and they should shake hands, you know, commercially or otherwise, to enable flow. Then comes enabling roaming for any one of those devices, and their traffic would flow between the two.
So my question actually is almost very similar to that. So I have a bunch of helium-based trackers. Am I paying Actility to roam to those other? I mean, how do I go and create an Actility account, and you then handle who I can roam onto, or is that how that works?
All right, so I mean, we can talk about one scenario. Say you have
That's kind of I mean, I'm Helium, but who knows? Somebody else is something else. I mean, I'm just figure out who do I pay.
So let me answer this question. Maybe it's the same thing. So how can I have my devices roam between, say, my private network and Helium, right? So we could be, yeah, I think that's what you're asking. So first of all, you need to have a network server of your own, right? That's where you would be provisioning your own gateways for your private network and your own devices, right? And then say you would like to leverage Helium coverage or any other public network coverage. For that, you need to set up roaming between you need to interconnect first. You need to have the physical connection in a sense, and you can do so by connecting your network server to ThinkPark exchange, the roaming hub, all right? And over that roaming hub now, we have the ability to push traffic between the two. But the next thing that needs to happen is there needs to be kind of an agreement. Either you set up agreement with Helium directly, or through Actility, we have the ability to buy frames for you and then push them to you. That way your device being provisioned in your home network would leverage your private gateways whenever they're in your venue or, you know, office and all that. And then when they wander away, when they're under the Helium coverage, their frames would clear the Helium blockchain because we'll be buying them for you and then providing them to you. But that's one setup.
So my actual situation is I do have Helium devices. So I saw your big graphic there at the beginning with all those names on it. I was like, ooh, very cool. I'll sign up with Actility, pay them X dollars, and now, other than those satellites, I can roam on to everything else. But that doesn't sound like that's...
No, it's not that simple, right? I mean, there needs to be an agreement behind it. Yeah. That there needs to be an agreement behind it. It's, being on the backbone doesn't mean that everyone roams with everyone freely, right? You know, there are
There's a
resources
product.
associated with these networks. So it's not that liberal, let's say, that free. There's one.
That would be on your device.
Oh, device.
So on this one, for example, I'm going to use the panic button. And so on this device, I do a number of clicks on it. And the device starts to blink red, telling me that it's in SOS mode. And so if I look at... Uh-oh, something disconnected. Let me see if I can... Oh, there it is. So it's back here. And so that's my device. Let me decode that data. And so here, for example, the idea is now the device is sending that SOS flag. And the idea for that device is once the SOS is activated, for that particular device, it means that every, I think, 2 minutes is going to send a message with its positioning. And so that would be an alert. So on the application side, you could have different ways of handling that SOS flag. So yeah, to handle that specific alert. Let's see if I can have more. And there it is. And so even when you have an alert, so this one is the 04, so it's not this one, 06. Yeah, so the alert will take precedence to your other configuration because you go into the alert mode, so the device will prioritize that.
Okay, any other question or request for further demonstration? Maybe you can move with the device? Is it going to?
Sure. I think let's see where he is now. So that's where Alper were. Then he moved and can move over there. And in this case, let's see. Let me get the next message. 631. Send data. If I reload my data here. And so it's telling me, okay, and so here on the map I see my last message and I see that it's an SOS message that was sent. So you, in this case, you see on the app, okay, this was an SOS location. Let's see if I have another one. Yeah, the next one should be in a minute. So basically here I'm looking at the 06 device. So I had my last message at 31, and so the way they're configured is when they're on that SOS every 2 minutes. So I should have another message right about now.
And we can get the next question while waiting.
Any other questions?
talking about earlier, I was saying the nice thing you could see was that there were no packet loss. And so you see, so in here we were on activity network, helium here, so 21, 22, 23, 24, 25, 36. But here, between those two messages, we had 3 packet loss. So I don't know if my next message will be received or not, in that case, because of the packet loss. And there I have 32 here. And if I go back on my map, oops, wrong side. So you see my second SOS message, so Alper moved over there, and so you have the movement detected here.
Yay.
And again, it's in relation to the 3 Bluetooth beacons that I set up before, and you can see then the small white box with written "Do not touch" on it. So you want to see. Just really a coin cell with a Bluetooth beacon in it. And so another thing that I did before is also configure the devices, because I assumed that with all of us being working in high tech, there's probably a bunch of Bluetooth devices in the room. So I did configure the device to filter on the specific addresses of those Bluetooth beacons to be able to actually show something.
How was the battery life of the beacons?
Very good question. I don't know. I do not know. I have no idea. I would say a few months, but I never measured them.
And what about the battery life of this mini tracker?
So this is also
this alert mode. How long is it going to last?
So this is a difficult question to answer, because it's very different if you're doing, even if it's the SOS mode, if you're doing that on BLE or if you're doing that on GPS. GPS being the technology that will use the more energy on the tracker. So when you're building your configuration for your tracker, what you have in mind is what is the most important for a specific use case. Do you want the best accuracy and you don't really care about the battery because maybe the device is plugged, always charging, maybe in a car? Or do you want to save the battery because you want your device to last at least that amount of time? So you're always going to balance the technology you're using, how often you're going to send positions. That's basically, and the accuracy you want. In general, for normal configuration, it's at least a few weeks. And so those are really the small ones. You have bigger ones that have bigger batteries, and you can take years with the tracking position, but like 24 positions a day, for example, is a typical configuration.
Let's see if we have got this last position as well.
Let's see. So I have one at 35, I have 2 of them. Let's see on the map.
Why does the map start from Paris?
It's my Frenchness coming out. And exit. Where are you? But this one is 35. The last position was still over there. Now it's 37. Since you moved, I will need the next one. Let's see. And another thing you see that we discussed earlier about someone was saying that you don't necessarily want to always have your device hack its messages, and that's very true. You usually don't want to do that. But there are a number of techniques and mechanisms that you could put in place to still increase the reliability of your messages without using the acknowledgement mechanism. In this case, the device is sending usually twice its messages. That's how we configured them. And when you're sending those messages, you can play on things like using different spreading factors, again, to increase the chances of receiving the message on the gateway side. So now I do have your position at 37. Let me reload that. And so we see the third position. Yeah, not as accurate as the previous one. You were too bold, Alper. Yeah. But yeah, for this one, I'm still pretty happy with that in the sense that it's a setup in itself. Putting the beacons and drawing the map on the application took less than 5 minutes, and we still have a relatively accurate position. For Bluetooth, ideally, like I have 3 beacons for a room that size. For rooms that size, you would probably want to increase the number of beacons and put them in every 5 meters, maybe something like this. That would greatly increase your accuracy. But yeah, for 3 beacons on a room like this, it's really not bad, I think.
Okay, more questions? So, thank you very much, Thior. Thank you, Albert.